The universe expands, yet the truth remains, still within.
Why does the universe exist at all? Why does anything exist? It may be the most profound question humanity has ever asked. Every star in the sky, every atom in your body, every galaxy drifting through the cosmos exists within a universe that somehow came into being. Yet when we step back and ask the simplest possible question, why there is something rather than nothing, the answer becomes surprisingly difficult. For most of human history, the origin of the universe was explained through philosophy, mythology, or religion. Ancient civilizations created stories about cosmic creators and primordial forces shaping reality. But in the past century, science has begun exploring this question in an entirely different way. Using mathematics, observation, and experiment, physicists have started to reconstruct the earliest moments of the universe itself. The modern scientific story of the universe begins with the Big Bang. Around 13.8 billion years ago, the universe was compressed into an extremely hot and dense state. Space itself was incredibly small, and the energy density was unimaginably high. In the first fractions of a second, the universe expanded rapidly, cooling as it grew. As it expanded, fundamental particles formed, followed by atoms, stars, galaxies, and eventually planets. Everything we see in the cosmos today can be traced back to those earliest moments. But the Big Bang Theory raises a deeper question. If the universe began in this extremely dense state, what caused it to exist in the first place? What created the conditions that allowed the universe to emerge? To explore this question, physicists began examining the laws of nature themselves. One surprising discovery is that empty space may not actually be empty. According to quantum physics, even the vacuum of space contains energy fluctuations that constantly create and destroy tiny particles. In quantum field theory, what we call empty space is actually filled with fields that permeate the entire universe. These fields are constantly fluctuating due to the uncertainty principle, a fundamental rule of quantum mechanics. Because of these fluctuations, pairs of particles can briefly appear and disappear, even in regions that seem completely empty. This strange phenomenon suggests that the universe may not require a traditional creation event in the way we once imagined. Instead, some physicists propose that universes could spontaneously emerge from quantum fluctuations in space-time itself. In certain theoretical models, the total energy of the universe may even be zero. This sounds impossible at first, but it becomes plausible when we consider that the energy contained in matter could be balanced by negative gravitational energy. If these energies cancel out perfectly, the universe might arise without violating any physical laws. In other words, the universe may exist because the laws of physics allow it to exist. This idea challenges the way we usually think about creation. Instead of requiring an external cause, the universe could emerge naturally from the properties of quantum fields and space-time. Another fascinating theory proposes that our universe might not be the only one. Some cosmological models suggest that our universe could be just one region within a much larger structure known as the multiverse. In this picture, countless universes may exist, each with different physical properties. Some may have different numbers of spatial dimensions, different strengths of physical forces, or entirely different physical laws. Most of these universes would likely be hostile to the formation of matter, stars, or life. But a small fraction might possess the precise conditions required for complex structures to emerge. This idea is connected to what physicists call the fine-tuning problem. The laws of physics appear to be delicately balanced in a way that allows the universe to exist as we know it. If certain constants were slightly different, stars might never form, atoms might be unstable, or the universe might collapse too quickly for galaxies to develop. Some scientists interpret this fine-tuning as evidence that many universes exist, each with different physical parameters. In such a multiverse, it would not be surprising that at least one universe, ours, has the conditions necessary for life. But even the multiverse idea raises deeper questions. If multiple universes exist, what generates them? What determines the laws that govern those universes? And why does the largest system exist at all? These questions push science to the boundaries of what we can currently understand. Another possibility is that the universe may have no true beginning. Some cosmological models suggest that the Big Bang was not the absolute beginning of existence, but rather a transition from a previous state. In these models, the universe may undergo cycles of expansion and contraction, endlessly renewing itself across cosmic time. Other theories propose that our universe could have emerged from the collapse of a previous universe or from quantum processes occurring in a larger cosmic environment. Each of these ideas attempts to address one of the deepest mysteries in science: how existence itself can arise. What makes this question particularly difficult is that our current physical theories break down at the earliest moments of the universe. When we trace cosmic history back to the first tiny fraction of a second after the Big Bang, the equations of general relativity and quantum mechanics become incompatible. To fully understand the origin of the universe, physicists believe we will need a theory of quantum gravity, a framework that successfully unifies relativity and quantum physics. Such a theory could reveal the true structure of space-time at the smallest scales and provide insight into how universes can form. Some physicists believe that space and time themselves may emerge from deeper informational or quantum processes. If this is true, the origin of the universe may not involve space and time in the way we usually imagine. Instead, space and time might appear only after certain fundamental conditions are met. This possibility suggests that the universe may be far stranger than our everyday experience suggests. What we perceive as the beginning of time might simply be the point where our current description of physics becomes incomplete. The deeper science explores the cosmos, the more it reveals that reality is layered with complexity and mystery. The question of why the universe exists may never have a simple answer, but that does not make the question less meaningful. On the contrary, it may be one of the most important questions humanity can ask, because every discovery we make about the universe brings us closer to understanding the fundamental nature of existence itself, and the search for those answers continues. Across laboratories, observatories, and research centers around the world, scientists continue pushing the boundaries of what we know about the universe. New telescopes scan the sky in unprecedented detail, capturing light that began its journey billions of years ago. Particle accelerators recreate conditions that existed fractions of a second after the Big Bang. Sophisticated detectors search for particles that have never been seen before. Each experiment is a small step toward understanding the deeper structure of reality. Yet, with every discovery comes a deeper realization. The universe is not a simple system waiting to be fully explained. Instead, it appears to be a vast and intricate structure layered with mysteries that reveal themselves gradually. The more we learn about the cosmos, the more questions emerge. Why do the laws of physics have the precise values that allow galaxies and stars to form? Why does space have 3 dimensions? Why do the fundamental forces of nature behave exactly the way they do? These questions remind us that the universe is not just a physical system. It is also an intellectual frontier. In the early 20th century, scientists believed that physics was close to completion. The laws governing motion, electricity, and thermodynamics appeared well understood. Many researchers thought that only minor details remained to be discovered. But then quantum mechanics and relativity completely transformed our understanding of nature. Concepts that once seemed certain were replaced by ideas far stranger and more profound. Today we may be standing at a similar threshold. The discovery of dark matter and dark energy has already shown that most of the universe remains invisible and poorly understood. Observations suggest that roughly 95% of the cosmos consists of components that we cannot directly detect. These mysterious forms of matter and energy shape the evolution of galaxies and the expansion of space itself. Yet their true nature remains unknown. Some physicists believe that solving these mysteries could require entirely new theories of physics. Future discoveries might reveal unknown particles, hidden dimensions of space, or new fundamental forces. The universe may contain structures and phenomena that lie far beyond our current models. Just as the discoveries of relativity and quantum mechanics revolutionized science in the 20th century, the coming decades may bring insights that reshape our understanding of reality once again. But even if the deepest mysteries of the universe are eventually explained, the journey of discovery will not end. Science is not simply about reaching final answers. It is about refining our understanding, building better models, and continuously questioning our assumptions. Every generation of scientists inherits the knowledge of the past while also confronting the unknown. In this sense, the exploration of the universe is an endless process. Each new observation reveals another layer of complexity. Each new theory opens doors to further questions. The universe invites curiosity, exploration, and imagination. And perhaps that is the most remarkable aspect of all. The cosmos is not only a physical system governed by laws of nature, it is also a source of wonder. The night sky that humans have gazed upon for thousands of years still holds secrets waiting to be discovered. Every star, every galaxy, and every particle tells part of a story that humanity is only beginning to understand. When we study the universe, we are not just studying distant objects in space. We are studying the origin of matter, the evolution of cosmic structures, and the fundamental principles that shape reality itself. And in doing so, we are also exploring our own place within the cosmos. Because the atoms that form our bodies were created inside ancient stars. The laws of physics that govern distant galaxies also govern the particles within our cells. The same universe that formed billions of years ago continues to evolve, and we are part of that unfolding story. This realization connects us to something far larger than ourselves. The universe is not just something we observe from a distance. It is the environment that made our existence possible. Every discovery about the cosmos is also a discovery about the conditions that allowed life, consciousness, and curiosity to emerge. And that curiosity drives us forward. It drives scientists to build more powerful telescopes, more advanced experiments, and deeper theories of nature. It drives humanity to keep asking questions that once seemed impossible to answer. Why does the universe exist? How did space and time begin? What are the fundamental ingredients of reality? These questions may never have final answers. But the search for understanding is itself one of the greatest achievements of human thought. Because every time we ask these questions, We expand the boundaries of knowledge. And every time we look deeper into the universe, we discover that reality is even more extraordinary than we imagined. Still, within,